you were in Madrid.
Yes. And so my Spanish was much better then, and I've taken classes, but not too
Okay,
many.
okay,
But
okay.
my Spanish was okay. I could talk to people and I could understand,
Ah, that's
but
perfect.
I don't use it that often here, and that's yeah. But
No, no problem. It's okay in English, and also the questions will be in English. So
yeah, I know students speak English, but yeah,
yeah,
it feels a little bit bad not to do it in the right language.
yeah, no, it's okay. Yes. We are used to listen in English. Is the language of the science, so it's okay.
Yeah. What is your area of research or
Oh,
expertise?
yes, sorry. Well, I'm new in the department.
Oh,
It's
okay.
my first year as
Oh,
an associated research, and I
uh-huh.
basically study. Well, I'm making these models of data simulation and forecast.
Oh, okay. Wow.
Oceans. I'm very interested on your talk.
Okay.
Uh, because you will speak about forecasting systems, right?
I will, but kind of on this very 10,000-foot level,
Okay.
but it's kind of identifying where the weaknesses are and where we're going with this whole project. So I'm kind of up here in terms of forecasting in terms of the details, but I can speak to some of the issues, though I don't do that exactly myself.
That's perfect. And I also working on some scale processes, more theoretical works, and also turbulence.
Okay.
I'm interested in I think in
And then
sometimes it's hard to me to be focused on one topic. But I think these three topics are my
you're
uh,
yeah, kind of
research interest. Let's say yes.
yeah, yeah.
Yeah.
That's it. Yeah, it's interesting where you're. So I would imagined I would spend my life doing coupled air sea modeling, and then I've been in Fairbanks for 24 years, and I've actually not done any of that. I've done other things, and I'm actually now doing some coupled air sea modeling with a student again after many
Yeah.
years. I've analyzed output, but I haven't been running the models myself, which
Yeah.
is what I was trained to do. So who you never know what you end up doing.
You never know. Sometimes
Yeah.
I said I would stop to do modeling because it's hard sometimes. You know what I mean.
Yeah.
And but the life is a game approached me to the models again, so I'm not able to separate from models.
Yeah, that's right. And if you have those skills, they're very useful. And
Yeah.
but but um but I started out as an observationalist for my master's, but I was very interested in modeling. That was why I went into this area,
Yeah.
into atmospheric science. So
Yeah.
I don't, yeah, it's but models in the Arctic are not so good. So I've spent more time with observations
I
because
cannot imagine modeling the Arctic. It's
yeah.
challenging, totally. Yeah.
It's gotten much better in the 20 years. It's improved, but there's still
Okay.
quite a ways to go. Yeah.
Yeah, I can imagine.
So
Yes.
I think
Yeah.
that is part of the reason I ended up going back to observations mainly, or something somewhat more theoretical. Those models that are now there's so many models that are run, so and there's lots
Uh-huh.
of variability and change you can analyze in them. So,
Yeah.
but
Yeah, because you in Arctic and Antarctic as well, you need to take account for the ice. So it's another compartment. And it's not only the sea, the water, the salty water, it's also the interaction with the ice.
and the land models are not well represented because there's the frozen processes which
Mm-hmm.
really change, and the vegetation's very different. So
Oh,
in most models, the vegetation is still it's gotten better, but it
yeah.
still has ways to go. it's not good enough to be able to do the types of experiments I would like to do about tundra sea ice interaction, for example.
Yeah.
So, but hopefully someday.
Yeah. And what about the satellite imagery? You know, how much well worked? Oh, here's Teresa.
Hi,
Hey,
Teresa.
Omar. Hi,
Hola.
can you hear me? Can you
I
hear
can
me?
hear you. I can
Excellent,
hear you.
excellent. Nice to see you. That's great.
It's been a long time. It's been a few years.
Yeah, since San Francisco, I think.
I think, yeah, San Francisco AGU.
Exactly.
Yeah. Have you seen Jose?
Yeah, no, I've been in. Well, I think I saw him in Sao Paulo before the pandemic.
Oh, okay. I think
Yes.
I probably haven't seen him even in longer than I saw you. So,
Actually, I saw him in the IGU, but
okay.
I went 2 years ago
Okay.
and I met him there.
Oh, I was there, whatever, 2 years ago. Huh. I missed him. Okay.
Or maybe it was before the pandemic. I
The
just forgot.
2019. Yeah. Anyway.
2019. That's right.
Yeah.
It was
Yeah,
2019.
yeah.
Yes.
Oh, I only went for one day because I had this proposal due and I had to change my whole schedule. That's right. So I went for one day, so I didn't see anybody. Yeah.
Okay, okay.
Boy.
Yeah. So
Anyway,
is your family well?
they are well. My son is gone last night to Washington D.C. for a school trip, and he's
Nice.
graduating from high school already, which is hard to believe.
Uh-huh.
Um, and um, and and David's doing well. He says hi.
Hi. Yes, tell him hi from me.
Yeah, we're just kind of marching along. How are you all doing? The weather looks beautiful.
It is nice today. We had a very dry winter,
Ah,
super dry. But the weather has been temperate, very nice, apart from not having rainfall. But
is wildfire a problem?
yes,
Yeah,
yes,
okay.
we had a wildfire in the last one was here in my neighborhood in
Ooh.
December 2 years ago.
Oh, wow.
Yeah, it was really scary.
Yeah, yeah.
Um,
We have a lot of wildfires in Alaska also from the
yes, it's amazing
lightning.
to think that Alaska can have wildfires.
But it's very dry. It's a polar desert in the interior where the boreal forest is.
That's right. But
And
I guess this year was wet over
we've
there.
had a lot of snow. We had 28 inches of snow in December 26th. And we had 1 inch of ice, which we
Wow.
called it our Ice Mageddon. And it still hasn't totally melted. It's melting very slowly.
Uh-huh, uh-huh. Yeah, I saw beautiful atmospheric rivers going up to the north, all heading out of our region. Just looking at them passing through. Yeah. Oh,
Yeah,
La Niña is to blame, I suppose, partly.
yeah, yeah. Is your semester almost finished?
Yes, actually, this week is
Okay.
the week of the thesis advances. All week it was full of thesis advances, and yes, the next we have quadrimesters
Okay.
every 4 months.
Yeah.
So the next one starts early May.
Okay, so little break. Or
Yeah.
this is the last week of class here, and then finals are next week. And then we have some summer classes, but then typically we don't start till the fall semester. Like most people don't take classes in the summer,
Uh,
like most regular students
uh-huh.
or graduate students. So
Yeah, I suppose people will join little by little because we have so many thesis advances that
people have been, yeah, busy.
yeah.
Sure.
Okay, so it's
Hello, hello, hello,
hello.
Tere.
Hola, Jose.
Hey,
Hello,
Jose,
Sheila.
hola.
Uma. Nice to meet you, Uma.
Nice to meet you.
You are very welcome to our department.
Muchas gracias.
Jose is the chief, department chief. How you say?
Department chair.
Head of the department.
Something
Yes.
like that. Okay. Facebook is working very well.
Excellent.
We have you at Facebook right now.
Ah, great. Yes, Facebook Live.
Good. So I think we can start. We are on time, so can you hear me? Because
Yes.
I'm okay. Thank you, Ma. Well, I will switch to Spanish to introduce you. Buenos días a todos, una vez más aquí en los seminarios departamentales del Departamento de Oceanografía Física de CICESE. Hoy nos acompaña la doctora Uma Bhatt. Déjenme comentarles un poco sobre Uma. Ella obtuvo su grado en la Universidad de Pittsburgh y maestría y doctorado lo realizó en la Universidad de Wisconsin-Madison en el área de ciencias atmosféricas. También realizó un postdoctorado en Cola, Carbenton, Maryland, sobre variabilidad climática y realizó un sabático en el Departamento de Biología Vegetal de la Universidad Complutense en Madrid. Es profesora desde el 2014 del Colegio de Ciencias Natural y Matemáticas de la Universidad de Alaska, directora asociada de la NOAA, SICOES y directora de CIFAR. Ha dirigido al menos 7 tesis de doctorado, 14 de maestría, ha ganado 12 premios de prestigio internacional y cuenta con más de 130 publicaciones indexadas en revistas de alto impacto. Hoy la doctora Uma nos va a hablar sobre, no sé si están viendo mi pantalla, pero sobre Sea Ice Prediction Network, an approach to improving and communicating seasonal sea ice forecast. Muchas gracias, doctora Uma. Adelante.
Gracias. Thank you for this opportunity to present. And again, I apologize, I have to do this in English because my Spanish is not good enough.
You can share the screen.
So hopefully you're seeing my presentation slide.
Yes, perfectly.
All right, well, welcome everybody. So I'm going to tell you about the Sea Ice Prediction Network and talk about seasonal sea ice forecasting done as a group. And this is a project that's funded by the National Science Foundation, and I'm the organizer of this group, but that's a very large group of Arctic and mid-latitude and Arctic scientists and researchers who are working on this. And I'm going to first start by giving you a little bit of background about sea ice. Maybe some of you are familiar, but first of all, sea ice is a very challenging thing to model because sea ice is not flat. And these are some pictures showing something called pressure ridges. When pieces of sea ice move together, they build up these large ridges. These ridges can be up to 10 meters in height. And there's some photos of humans standing with sea ice ridges. And these ridges can be quite big, as you can see from the bottom here on this photo taken off of the northern part of Canada near Ellesmere Island, where the ridges get particularly large. So sea ice has a lot of structure. It's a challenging thing to model. And I think we're not at a point where we're modeling the variability in the sea ice itself. Those properties that needs to be improved. Let me go over the climatology of sea ice. The plot on the left shows us the month of March. March is the month when the sea ice reaches its maximum extent in the Arctic. And this is shown by the pink line, which is the average from 1981 to 2010, the climatology. And underlaid upon that is the March 2022 sea ice from last month. You can see that last month, this year in 2022, our sea ice was pretty close to the long-term mean, except for in a few locations, like in the Sea of Okhotsk. I'm not sure if you can see my pointer, but And then on the right-hand side, sea ice reaches its minimum extent in September. And this year, in this last September, shows September of 2021, sea ice extent in the Arctic, and the pink line shows the long-term climatology. So it was quite a bit less than what we have on the climatological average. It wasn't a record low, but it was a low, and I'll show you more about that. So I'm going to show you a movie. It'll probably be somewhat slow, but I'll share these slides so you can go visit this movie yourself. And what this is a movie that NASA makes every year that shows sea ice extent over the satellite record in September, the minimum. And you can see it has a lot of structure. There's a lot of movement in the Atlantic side and in the Pacific side of the sea ice. The thickest sea ice is north of Canada, where there is sea ice permanently. We haven't lost any during the summer yet. I mean, we're losing it at the edges, but the area of sea ice is still present there. It's shrinking from the Eurasian seas and the North American seas. And then the red line shows a time series of what happens, what has happened every September. And the sea ice is declining, as I'm sure you have heard in news stories and elsewhere. Hopefully my Zoom will continue. So everything I've told you so far has really focused on sea ice extent, which is essentially the sea ice area. We're looking at it from satellites, and we're just looking at how much there is. Sea ice volume is actually very, very important. And this is a picture from Climate Central that is really a simplification of how thick sea ice was in the 80s, and this is based on U.S. Navy submarine measurements that they took from underwater. Basically, you use sonar to see how much of a keel there is in the sea ice, and that tells you, how much there is sticking up on top. So that gives you a really good measure of sea ice thickness. So in the 80s, we had sea ice thickness up to 12 or 15 meters, and now it's significantly decreased. So we're losing area, but we're losing volume even faster. So we don't have great measurements of Arctic sea ice over the satellite record. We have good satellite measurements of sea ice now for about 10, 12, 15 years. So there is, that record is developing, but it's not long enough. So what we use is a model with data assimilation, and this particular model, that's one of the most commonly used models, is biomass, and it's run at the University of Washington. And what this plot on the left shows is the total thickness, and this was March of 2022. So the thickest ice is north of Canada, and it basically what happens is ice forms on the Eurasian side, and the prevailing winds help to move this ice and help it pile up north of Canada. And so the thickest ice remains here, and the ice shrinks away all around the Atlantic side as well as the Pacific side. And this plot on the right shows what the ice anomaly is. So throughout the Arctic, all the anomalies are negative, these orange colors. So in March of 2022, the ice was much below normal. And I don't know exactly what they use for the climatology here. I'm assuming 1980 to that 30-year period starting then, but I'm not sure. Another way, I think one of the great things that's happened is people are really being creative about how they visualize a lot of the data. And this is a researcher named Zach Labe, who's a researcher right now at a postdoc or researcher at the University of Colorado State. And I think he's done he did the previous plot also. But he has created these plots that show the volume of ice, the seasonal cycle, one line for each year. And he's color-coded them. So in the 80s and 90s, based on the biomass data assimilation data set, the ice reached This is thousands of cubic kilometers. The volume of the Arctic sea ice was way up here at 33, and now it's somewhere around 23 as of March 2022. And again, we can see this shift in the volume, which is worrisome, or certainly, it's happening. So now, why does sea ice matter? Sea ice matters because it has, like any change in the climate in the ocean, has a variety of impacts, and I'm just going to mention a few here. First of all, sea ice is strongly, intimately linked to this notion of Arctic amplification. As the climate has warmed, the climate at higher latitudes has warmed 1.5 to 2 times more than the global average, because when you get rid of sea ice, the albedo of the surface of the Earth changes significantly. The ocean's able to absorb heat from the sun in the summer, and because the sun shines 24 hours throughout the Arctic, and that really warms up the ocean, and it really amplifies that temperature warming. So that's the ice albedo feedback that gives a primary mechanism for Arctic amplification. But we also get Arctic amplification from tropical effects. As the climate has warmed, tropical convection has become much more vigorous, and that's transported more moist heat, moist static energy into the tropics, into the polar regions, sorry. And that transport of moisture is another form of Arctic amplification. And typically that signal is more visible throughout the depth of the atmosphere, whereas the ice albedo feedback signal stays closer to the surface. So again, those are the two main mechanisms. There's some other mechanisms that contribute to Arctic amplification, but those are the main ones. So in the Bering Sea here, that's just south of Alaska, typically we have sea ice that's building there into the, starting in the fall. And what's happened in recent years, there's been much less sea ice in the fall in the Bering Sea, and we get a lot of storms that come up through the Pacific in the fall, and those storms are their impact is minimized on coastal regions when there's sea ice, but when there isn't sea ice, it leads to larger wave heights and coastal erosion. And a very large percentage of the Earth's global population lives along coastlines, so there's immediate human impacts due to that. The other topic is this topic that is called the wavy jet stream, and when the Arctic is generally cooler, we tend to have a stronger polar vortex and a more zonal jet stream. But as the Arctic has warmed up, the north-south temperature gradient has decreased, and that everybody agrees on. The other part, which is the polar vortex, has actually weakened because of this weakened temperature gradient, and it's led to a more wavy jet stream. This is I call this is listed here as possible because people are still debating this, though I think the evidence is certainly growing. But when we get a wavy jet stream, we get these cold air outbreaks in Europe and in North America, and we are getting these extreme events related to cold temperatures. And again, people are still scientists are still debating whether it is a direct impact due to Arctic sea ice loss. And the last picture I have here is something that's kind of near and dear to my heart, is the tundra vegetation. And tundra is this narrow strip of land close to the ocean. It's a maritime biome. And 80% of Arctic tundra is within 100 kilometers of the Arctic Ocean. And what we find is, over the satellite record, we have measurements of NDVI, the Normalized Difference Vegetation Index, which measures the vegetation productivity. And we find that overall the Arctic is greening, but of course, as we've added more years to this record that's now 40 years long, there's interesting patterns developing. There's areas of declines of NDVI, and so I spend a lot of my time thinking about that. So this is let's talk about prediction now. This is the time series of September mean sea ice over the satellite record from 1979 to 2021, and the first record low occurred in 2007. And, I'll be honest, a lot of the Arctic researchers, some of the more senior, crusty folks were really surprised. And what this did is this really galvanized a community, and that's how SIPN was born. There were a bunch of Arctic scientists at a meeting in Seattle talking right after this record minimum. That surprised people, that we'd lost so much sea ice so quickly. And one of the NOAA program managers said, well, why don't you start a pool and get people to predict what they think the sea ice will be in 2008, and this will generate interest in sea ice and sea ice forecasting. So from 2008 to 2013, this was a grassroots activity that people volunteered their time, and they started collecting forecasts and putting them together. And there were a variety of different forecasts, and I'll tell you more about that. And then from 2014 to 17, they were able to get funding from the National Science Foundation, and that was called SIPN Phase 1. And during that phase, they started including Alaska forecasts, and a component called SIPN South that started towards the end of this period. And this is Antarctic forecasting. And then in 2018, a little bit before that, I got pulled into this. I wasn't part of it before this, but I was at the periphery of it because I spoke to the researchers. So I ended up getting entrained and being part of leading SIPN 2. So we got funded by the National Science Foundation, and we continued the Alaska forecast. We expanded them. We expanded looking at some other aspects, which I'll show in a minute. And one of the other things we did is at the University of Washington, Cecilia Bitz got funding to have the SIPN portal, because people were just contributing one number. What is the mean September sea ice? And that's a good place to start, but you really need some spatial information, and for that you need some sort of data science aspect. And now we actually, this past Monday, we just submitted the SIPN 3 proposal that we spent a year working on, and it's expanding and taking this work forward. And hopefully we'll get funded. So, I think one of the really interesting things about SIPN is it's created this unique network that's brought diverse people together, and I'll tell you about some of the groups, to think about this challenge that's a societally relevant problem. And I'll talk about some of the societal relevance. The Sea Ice Outlook, which is the collection of the forecasts of the September mean sea ice, now has a 14-year record. And this is a plot that shows the number of contributions each year. And it really has a two-prong. There's a part just to make it an inclusive network, build the network out, but to also engage the public and stakeholders to get them interested in thinking about this. So it makes it a bit complicated. You can see here there's a variety of different types of models. There's dynamical, shown in green. So those are geophysical fluid dynamical models, ocean ice or ocean ice atmosphere. Then there's mixed. People that use mixed maybe have dynamical and statistical. Then there's statistical. And what's happened with the statistical is in the last few years, people have included machine learning, and that has improved skill. And then there's heuristic. Heuristic can be, there's a primary school in Japan who's a middle school in Japan that's been submitting forecasts for the last 8 years, and it's driven by their teacher who really wants to get his students involved in statistics and math and applying it in a practical way. And this teacher has even switched schools, and he's continued doing this. So it's actually nice to have young people involved also. And their forecasts are in the heuristic category, but they're mainly statistical. So the names at the bottom are all the people who have contributed to this project kind of on the leadership level. And then this word cloud that I created is all the forecasts that we've gotten between 2018 and 2021. So if your name shows up multiple times, you provided more forecasts. And it's an international group. There's contributors from Asia, Europe, North America, South America. It's actually a very diverse group of people. And I think a lot of science is moving towards the need for groups to work together on these very difficult problems. And there's methods that need to be thought about in order for this to function. So in SIPN 2, we focused on collecting these sea ice outlooks for September minima. We continued that. We have a component that is developing new observation-based sea ice products led by Julian Struve. And you need good observations in order to initialize your sea ice models, in order to validate those models. We also, again, continue to engage the public, giving presentations and outreach, and we assess the accuracy of the sea ice outlook. And we're doing experiments on the sensitivity of oceanic heat. My student is looking at heat that's coming in through the Bering Sea. What kind of predictability does that provide us for Arctic sea ice? And we also had a component where we looked at wanted to, for a lot of the environmental work that we do, we don't have a good economic value of the forecasts or the science. So we had an economist who's been working with the crabbing industry to figure out what is the economic value of sea ice forecasts in Alaska. So this is the signature product that we created. So this is the September 2021. So in September 2021, we collected forecasts at the beginning of the month for the mean September sea ice. The observed sea ice was at 4.92 million square kilometers. This is a rank ordered plot of all our contributors. Here's the primary school down here at the bottom. Primary school actually did pretty well in this blue category. And these are all the different types of forecasts, and machine learning was pulled out separately from statistical. You can see the purple lines are the machine learning. You can see that this gray line shows the 2020 sea ice observation. So in 2020, we had 4 million square kilometers, so it was the second lowest of the satellite record. And then this dashed line shows the median of all our forecasts. So typically with these multi-model forecasts, the medians certainly do better than any individual forecast. You can see that there's quite a big range from less than 4 to more than 5 million square kilometers. So now, if we look at our median forecasts in July over the 14-year record against the full satellite record, there's a few things that become very clear. The forecasts, some years they're good, but there's still quite a lot of room for improvement. And there's times when you're in the forecasting business that in an echo chamber, people can feel very discouraged. Forecasting is putting all of the science that we do as atmospheric and oceanic scientists, and we're trying to apply it to something practical, and it's a challenging problem. So what this plot shows is summarized best in the next plot. This is that just the last 14 years, the squares show the median sea ice outlook forecasts in July. And this is the interquartile range showing the spread across the different forecasts, so the 75th and the 25th percentile. And then this is, the black line is showing the observed sea ice extent. So the trend is actually not obvious once you pull it out from the previous plot. But what we see is our forecasts do better when the observations are close to the trend. We're good at getting the trend. We're good at forecasting close to the trend, but when it's deviating either direction, we're not in our forecast. So we've summarized the slides that I'm going to show you are kind of summarizing findings from looking at all these forecasts. Like, what have we learned? Because that's what's helping us go forward. Now, this story is just one of the strangest things, and at first I didn't believe it. This was a summary done by one of our colleagues, Francois Massonnet. If you take sea ice predictions for a given year, they are most highly correlated with what the sea ice observation was a year ago. So this correlation is 0.84. This is much, much higher than the correlation of, say, the 2021 forecast with what actually happened. And it's still a puzzle, and we don't understand it. And, I'm going to add if we look at how these are the lag 1 correlation shown with the star here. If we look at all the models, we have a 0.84 correlation. If we look at I thought, okay, this is dynamical models and there's persistence in those models that's continuing for a year. But I don't think that's the case, and Francois certainly doesn't. The dynamical models certainly have the higher correlation, but the heuristic as well as the statistical still have a fairly large, significant correlation. And, you know, we're wondering if people maybe get, you know, they forecast in 1 year and the observations are much lower, so they adjust their forecasting method. So there's some human activity that's going into this. So then the following year they forecast much lower than what happens, partially because also the sea ice goes up and down. But again, I guess right now our thinking is there's some human social element that's explaining what's going on. But it's one of the mysteries we've been thinking about. In January of 2021, we held the SIPN sponsored a virtual forum for all our contributors. We had really good turnout. And I think one of the best things that came out of the forum was that people had a bunch of ideas of things they wanted us to do. So we implemented them in 2021. And up to now, we've been collecting total Arctic sea ice values. So, you know, 4.2 million square kilometers. And, you know, I was trained as a tropical meteorologist, and for a lot of ENSO forecasting, we always look at the anomaly because we can get the anomaly better than the total, partially because each of our forecast models have some sort of bias. So we said, okay, is the difference between the spread between all our different contributions due to the model mean biases? And the answer is basically no. When we asked for the anomaly forecast, these are not all groups submitted anomaly forecasts. We still had a very large spread, and over the course of the season, the root mean square error did decrease, which is good as we get closer to the month of September, from early September. But still, we were not able to narrow that enough. So the conclusion is mean biases in the model are not the reason. So again, this is an activity that we did because it was initiated by the community. And I think it's a good way to answer these questions and solve these problems as a group. Another thing the community wanted were September forecasts. So normally, all these years, we've collected June 1st initialized, July 1st, August 1st. We thought September just didn't necessarily make sense because it's so close to, you know, September 1 initialized forecast for the month of September. But this year, because the community wanted it, we picked them. And while the median error for the 3 different kinds of models, there's black is dynamical, red is machine learning, blue is statistical, while the errors do decrease, the median errors do decrease, they get closer to the observed, we do see that even in September there was a large spread. And another plot that I haven't shown is the spread was still disturbingly large in September. So even at short timescales, there are things that we're missing, and that needs to be explored further. We have been collecting Alaska forecasts since 2016. These are dynamical, mixed, and statistical, so kind of half and half dynamical and statistical. These are the number of forecasts we've gotten over the last 6 years. And I would say in the Alaskan seas, there's very large kind of decadal, multi-decadal variability in the sea ice record. And again, it's similar. If you're close to the trend, we seem to do better, but when we don't do as well when it's farther. But we're still doing a little bit better in the Alaskan seas than we do over the whole Arctic. And again, regional information is very important because that one value for the Arctic, while it's a good indicator of what's going on, it's really pretty useless for anybody who wants that for making decisions or understanding what's happening, you know, off the coast of Alaska. should I take my ship out or not? So again, regional information is important for stakeholders. But the large-scale indicator is important to communicate to a broader public. So this is, so some of the groups submit spatial data, and this is sea ice, spatial sea ice probability forecasts. So these are different models. There's 10 different models, and then the multi-model mean, and then the standard deviation of the forecast. And the black line shows the observation. And the model, the multi-model ensemble was evaluated against a forecast of climatology. So if you forecast climatology, where this multi-model mean is doing better than just forecasting climatology. So it is beating that. And climatology is a typical benchmark that we use. Again, it is, there's a lot of spatial variability, and some of this, there was sea ice that was stuck to the Eurasian coast that showed up fairly early in the forecasts. Even, this is towards the end of, this is August, but even in June, you could see this being captured in these spatial forecasts. And again, understanding the regional strengths and weaknesses is important for the stakeholders. So now I'm going to talk a little bit about other aspects. Our economist, Joseph Little, spent quite a bit of time talking to crabbers in Alaska. He went to several marine conferences, and he ended up going towards the crabbers, partially because Bering Sea snow crab is a huge money-making industry, and right now I don't remember, it's like several $1 billion a year. And basically, he talked to those folks, he showed them some of the plots that we present, and they didn't find those plots accessible. So that was very clear. We need to make our plots more accessible and understandable by a broader audience, not just scientists. And one of the things from interviewing the crabbers, crabbers are very interested in the sea ice location, the extent, so how compacted it is, what direction it's moving, then lower down the concentration and the stage. Stage is what type of sea ice is it? First year, how thick is it? And then the months that the crabbers are interested in is January, February, April. So up to now, we've been just collecting September minimum mean sea ice, partially because that is what one of the indicators that historically we've been keeping track of. So in our next proposal, we've included also collecting forecasts for March, because it has more, it has other interests, particularly for crabbers, and other parts of management would benefit from having information about what the sea ice is doing in the winter months, particularly in the Bering Sea. So again, these conversations have informed what we focused on in our next proposal. So the other piece that we've been including are the Antarctic forecasts, and this is led by Francois Massenet, who's a professor at the University of Liège. And Francois is actually a very bright light at our conversations, because what he keeps pointing out is Antarctic forecasting. This is the time series of observed on the left, and then under the blue shading is the June 2021, July, August, and September forecasts. And then the black dot shows what the forecast was verified at in September. And so it verified close to climatology, and then these are the forecasts. And as Francois said, Antarctic forecasting is way, way behind Arctic forecasting, because they're just started later. And so he said you should, even though the changes have been incremental, you should focus on kind of the positive changes that have occurred in that progress. So I think that with forecasting, you have to keep that in mind. So I appreciate that. I'll talk a little bit at the end here about the products for sea ice. So one of the products that's really important is knowing how much snow there is on the sea ice. And that's a very difficult quantity to get. You can get it from mixing reanalysis, satellite information, and snow modeling. And this is work done by Julian Strove and Walt Meyer and Glenn Liston. And these are some papers that are under review, but they are preparing a climatology of snow on sea ice, because the growth of sea ice is strongly dependent on how much snow there is. If there's a lot of snow, that insulates the ice, so the ice doesn't cool off and grow. So we need that. We need snow to properly model sea ice and to initialize our forecasts. The other thing we need is melt ponds. So melt ponds are these areas where the snow and the ice at the top of the surface of the sea ice melt. Underneath, there'll still be sea ice, but that really changes the albedo, and that can speed up how quickly the ice melts. And again, this is something that's parameterized in sea ice models, and we don't have a good climatology and a long-term record, and that's what Julianne has been working on. It's a melt pond fraction data set that is that they've developed and they've recently published. These are some photos, and this is a time series that shows melt pond fraction in June. So you can see the melt pond fraction goes up has gone up over the record, more melt, warmer Arctic, and it's decreased in September. It's partially decreased because there's less sea ice too. So to summarize, why is the sea ice outlook still lower than expected from other studies? So if you look at more theoretical studies of sea ice, we expect that the skill should be higher. And this is a question, fundamental research question we're focusing on in this next phase. And one of the things that we've done is we started collecting 20-year forecasts from a variety of different models, statistical as well as dynamical, where they use just one forecast system. And then all of those models are being compared. It's kind of a one-to-one comparison. What's happened, if you look at it, that's difficult to do with the sea ice outlook, because over the years, people keep improving their forecast models. So you can't go back and see how, you can't compare older versions of one model to what's current. So we're going back and doing this comparison that's consistent. We're also upgrading our portal. We're bringing in data scientists to make a space where the community can put the data and the spatial data for all these models, and to give the community a space where they can use it as a sandbox. We're going to do more regional evaluations, and we're going to continue with the September sea ice outlook, but we're adding March. And really the portal will help us answer why. We needed data scientists because we kind of reached the limit of what we as scientists could do. And up to now, we haven't made the forecasting a contest. We haven't talked about who did best, even though people ask about it, and we talk about that with individual forecasters. We would like to produce a multi-model sea ice outlook forecast and make it a weighted forecast that weights models based on their skill that we learn from this comparison that we're doing with all the different models. So it's a new phase, and it had to be talked about with the community to make sure they were good with it, but I feel like they are. People are ready to do that. It takes a while in order for people to be ready to do these things. Again, challenges to network activity is all these contributors are volunteers. We can provide a forum, we can provide support through the funding that we get, and we're going to host annual meetings for the community to get together and talk about sea ice forecasting. And the benefit to the contributors is when you run your own single model, you can evaluate it. But when everybody runs their models together, like in these model intercomparisons, it really helps you put your model in context. And I think it can speed up improvements. And there's always tensions between contributors because they're working on sea ice forecasting and they're competitors. But I think as we go forward in science, we need to make a space where we can work together more easily and think about collaboration over competition. So whatever, collaborative competition is the thing I've been calling it. And thank you so much for your attention. I'm going to stop sharing so I can see.
Thank you, Uma. Very, very interesting, amazing work, and very challenging, I think. Right? Not only because the scientific topic, but also because include the social part, right? So yes, it's an amazing work. Entonces, abrimos la ronda de preguntas para la doctora Uma. Saben que puedan hacerlas por el chat, también por Facebook, o levantar la mano y pues adelantarse. Es que disculpen porque estoy aquí. Cuauhtémoc, yes. Please, Temo.
Hello. Yes, thank you, Dr. Bhatt. Thank you for your very, very interesting talk. My question is, you mentioned a strong signal of greening around you showed us some results of greening around the Arctic coastline. And I was wondering if it ties into the sea ice albedo feedback. Does it interfere? Does it constructively, or what's the sign of how would it relate?
So tundra plants are temperature limited. So what has happened is it is part of the ice albedo feedback. What's happened is as the climate has warmed, the sea ice moves away from the coast much earlier. So as soon as the sea ice moves away from the coast, the land can warm up very quickly. You know, if the sea ice is close to the coast, it keeps that near coastal region much cooler. So since tundra plants are not moisture limited, they're temperature limited, that increases the available warmth or temperature that's available to the plants. So they've been able to their biomass has increased just simply from this temperature impact. But what's happened is as the sea ice decline has grown, there's now a bigger distance between the coast and the sea ice quickly. You know, early in the season, we're getting more cloudiness, and potentially there's some other feedbacks now coming into play that are complicating what happens initially, right? Initially, the sea ice goes away, it's sunny, it's warm, but now the sea ice goes away even earlier and it's cloudy and it's starting, you know, there's some summers that have been cool on the northern part of Alaska. So every year it's been a little bit different the last few years. And what we also see is in northern Canada, we see that index has been decreasing. And we have a variety of theories, and one of them is as the climate warms, at the most northern latitudes, you get more snow in the winter because you have more moisture in the atmosphere. So if there's more snow in the northern part on the tundra region, it takes longer for that snow to melt, and the plants cannot green up until the snow is gone. So it may be a snow loop or feedback. So sorry, it's more detail, but those are this is something I spend a lot of time thinking about or worrying about.
Yeah, very complicated.
Very interested in.
Many pathways for feedback. Yeah, thank you for your answer.
Thank you for the question.
Gracias, Temo. ¿Alguien más?
No.
Se había levantado la mano.
Hola.
Sí, adelante.
Report from Facebook. The Facebook worked very well. We have for the first time with captions. Thank you very much, Uma. Your talk is very appropriate for this Earth Day. Today, remember, is the Earth Day.
Right.
I have a question. I would like you to tell us about methods of in situ observation of sea ice.
Methods of observation of sea ice?
In situ, right?
So I'm not an expert on sea ice observations, but what my colleagues do is they go out on the ice, they survey it visually to describe what's going on, and they drill holes to see how thick the sea ice is. They also use it's a type of I can't think of the word. It's a type of radar. It's a thing you put behind a snow machine and you run it along and you can actually get a profile of the thickness of the ice. So that's a very nice way to figure out how thick ice is. And people use that in areas where they build ice roads because there are some oil wells off the coast of Alaska and they use a ground penetrating radar to measure that thickness. And then the other in situ observation is from submarines that are using upward looking, I guess, sonar to figure out how close, how much sea ice is underneath the surface of the ocean. So those are a variety of different methods used to measure the thickness of the sea ice.
Oh, thank you very
And
much.
people also use photographs and satellite pictures to quantify what kind of sea ice there is and interpret maybe how thick it is also.
Thank you very much, Uma. One recommendation for the people that have a question, that open your video for to see you in Facebook. Okay. Thank you.
Gracias, José. Teresa, adelante.
Uma, very interesting your presentation, and as Sheila said, very appropriate. No, Jose, very appropriate for the Earth Day. Now that we know that we are very much worried about the sea ice extent of the Arctic and the Antarctic. And I was wondering if the Arctic has seen any of the hot waves as we saw in the last few weeks in the Antarctic.
Yes, I believe there was a heat wave on the same day in both places. Somebody asked me about that, but I don't know if they were related, but yes, there've been quite a few heat waves in the Arctic, and that's been recorded for longer because people, have been out there measuring. Yeah, no, the heat. The other thing we're experiencing more in the Arctic are these large shifts in either very wet weather or very dry weather. There's a part of Alaska that got, a atmospheric river after having a prolonged drought, had an atmospheric river that led to landslides and actually several deaths. So it's something that community managers are very concerned about, and they want better understanding of when that happens. So
yes, that's what I was thinking about this year, because there were a lot of atmospheric rivers and a lot of snow. Well, I didn't check in Alaska, but you mentioned that
we had bad snow. Yes, we had snow in December that was related to atmospheric rivers.
And with this very wavy jet stream, yes, it's very common to have these extremes, very cold or very hot days. The other question that I had is, you mentioned that this project is supported by NSF, and there were a lot of people from different places. How much is involved Europe or Russia, for example, for this project, and you mentioned also the Antarctic. I wonder if there are scientists from the Big South participating. Now the Big South is a important issue to consider in research. So
yeah, I know less about the Antarctic group. I interact with the person who's part of both. But I don't know. I can connect you to Francois just to make sure that there's. I'm sure that there's connections with South America, but I don't know who they are. I'm not as familiar with them. In terms of we have European and Asian contributors to the Sea Ice Outlook. I believe, I'm not sure that we have any Russians, other than Russians who don't live in Russia. We have Russian contributors, but they live in other countries and maybe are immigrants. So there hasn't been a strong. But University of Alaska has very strong connections with researchers in Alaska because of permafrost, because of the tundra vegetation work that we do. The biologists I work with work very closely with the Russian community, and the war has really disrupted many people's field work and their collaborations. So, but that's a really good question. I have to go check, but as far as I know, I don't know that we have any Russian contributors. Write that down.
My last question was, you mentioned the social part, and now also we know that the climate services is an important issue. So this forecast is this part of a climate service, or it can be transformed into or totally different?
So that is our aspiration, right? Our aspiration from the beginning has been to make it into, get it to the climate service. So what we realize is we're still within the researchers where we've made some advances into climate services, but one of our partners will be NOAA in this next phase, and we're focusing just on how do you communicate and how do you visualize what these products look like. Because the sea ice crabbers looked at our webpage and looked at our pictures, and they told our economists, they're like, I don't understand this. This makes no sense, and therefore I won't use it. So basically, we need to go sit with those people and say, well, does this make sense? And we need to have that conversation to understand, what we need to do to make that communication better. So it really is kind of communicating our plots, which is something I'm interested in because it makes it easier to teach also if you make good plots and you communicate your message clearly. But yes, your people skills are tested in this day and age with climate services, right? We can't be scientists just sitting at our computer, even though as much as many of us would like to do that, that's kind of not possible.
Yeah, now we definitely need these translators for general public in order to be more visible, that our research is more visible to all the public. So it's important in any field.
Yeah, that's right. That's right. And I think it's a process and it's going to take some time, but I think the public is eager to understand, and we have to bridge that gap.
Thank you, Uma.
Thanks, Teresa.
Thank you, Teresa. ¿Alguien más? Julio Sheinbaum.
I had a couple of questions too. Thanks very much. Very, very nice talk. We are actually involved in, Sheila is involved in Antere, and many of us here are involved in translating some forecasting efforts into meaningful products so that people can use them. And but Terry already asked you about that. I do have a couple of technical questions. One is you talk about multi-model ensemble forecasts, but I wonder if you have single model ensemble experiments.
We in this next phase, I believe we do. We haven't up to now. We haven't had single model. We have the people who contributed have not. No, we have not had that yet.
So these are kind of deterministic forecasts, if you like. Each model makes one forecast. And,
yes.
And in that sense, the second question was can you give us a flavor of? I mean, I do wonder what is these, are these models more sensitive to in terms of the forecast? I mean, what makes them vary so much?
So one of the things, the other thing in this next phase that we're going to analyze very methodically is there's a big difference in what people initialize the models with, even though it's the same observation. So the initialization of sea ice and area and volume is different. Some of the models initialize with better ocean observations than other models. And again, there's so many differences, and we need to, part of this next phase is doing a apples to apples comparison. But I think you're exactly right that there's a lot of difference. But this is something I feel that sea ice models themselves may need improvement. And I think I haven't been able to get my sea ice modeler colleagues to admit to that. And the reason I say that is I look at it more as just somebody who's analyzed them. If you look at the daily sea ice, a movie of daily sea ice in the Arctic, you see so much movement in the marginal seas. It's just very active. if I take a climate model or a forecast model, the seasonal forecast model, and you look at that, it is very smooth. And that marginal ice zone doesn't capture what it looks like. And that, to me, that must be a very active region of heat transport from the ocean, heat fluxes. And if you're not capturing that, I feel like you're missing something very important, probably in a place where you have the jet stream and you have a lot of activity going on. So I think that's another problem, but beyond,
Thank you very much. Very, very nice talk. Thank you very much.
Thank you. Thanks for the great questions.
Thank you. Teresa, sí.
Can I continue a little bit of one of the question from Julio? Now that you mentioned, I can understand what is needed to initialize a dynamical model, but like what sort of variables go into a statistical model?
They vary a lot, and with this machine learning, it's somewhat of a black box to me, though I'm learning a bit more about that. There's a paper that came out last year by an author named Tom Anderson, who has used machine learning, and he comes from the computer science, data science, but he's worked at Cambridge in the Antarctic Center, and with a group of climate people. And his model does among the best job of capturing the extremes of Arctic sea ice. And what they trained their model on included CMIP runs, right? They felt there wasn't enough in the observational record. They've used climate model simulations to do some of the training. So so in these machine learning, people use all sorts of different things. In the statistical, some people use El Nino, kind of some very simple statistical, not simple, but kind of traditional things that we use in statistical forecasting. So, and then there's other statistical forecasts that are actually spatial, and I'm actually not even exactly sure how those work. Like, is there a different model in each grid box? I'm sorry, I don't know the details. That's
Thank you, Uma.
Yeah.
Thank you, Teresa. Yes, so I think nobody can understand all the details because it's a very complex problem. I don't know, no sé si alguien más tiene preguntas. Ya nos estamos acercando a la hora. Si no, una pequeña pregunta más para la doctora. Okay. Well, I think it's all, Uma. Thank you very much. We hope to hear about you and your work in the future. Once again, you are more than welcome if you want to visit us here at CICESE.
I'd love to visit you in person. That would be wonderful.
We hope that.
Yeah.
And if any of you are in Alaska, let me know. I'm in Fairbanks.
Of course, it's one of my dreams, visit Alaska. So
hopefully after the pandemic. But thank you so much for this invitation. It was wonderful to meet you all and to hear. It's always good to get questions because that's how you think, right? And that Zoom has really, really facilitated these conversations around the world.
Yes. No, thank you.
Adiós.
Thank you.
Bueno,
nice to see you. Bye.
Nos despedimos. Entonces, interesantísima charla de hoy. Así que hasta el viernes. El viernes que viene no habrá seminario. Así que pues hasta el otro ya, y creo que el que viene ya van a ser algunos, ya van a ser presenciales. Ahí se los haremos saber.
Muy bien,
Okay.
Gracias.
Vale, hasta luego. Bonito fin de semana.
Bye.
Bye.
Adiós. Adiós. Bye.